Okay, term 1, 11 maths B, diagnostic solutions. So we'll have a look at question 1 from topic 1, really from last year, doing some equation solving. Part A, there's no brackets, there's no fractions, so I'll just get rid of the brackets and go ahead and solve. Okay, so I'll expand these, 4y minus 32, okay, and write the rest as is. Actually, I'll write this new stuff in red so we can see what's happened, which shows a quicker way to change colors. Anyway, from here, I'm just going to collect like terms. So I've got 4y and plus 2y, so I'll be able to collect those as 6y. And then look at the numbers left over. I've got minus 32 and plus 5 will give me minus 27. That was a common mistake, that addition of negatives. Okay, from here, I'm going to get all the numbers to one side, variables to the other. So I'm going to actually add 27. I'll do it in 2 steps. You may have done it all in one. So 6y equals y plus 9. Okay, and then plus 27. So it'll end up at 6y equals y plus 36. Okay, from here, I'll bring the y to the other side. Okay, really don't need this many steps. Wrong colour. So I've still got the 6y there. That's why this y disappears. Okay, from here I'll have 5y equals 36, and then I can divide by 5. And typically just leave the answer as an improper fraction. Okay, question 2, there's fractions involved, so there's a few different strategies. I'll do the common denominator strategy and then show you what the other strategy would have looked like. So I'm going to try and get everything to have a denominator of 3 in this case. The p minus 6 can stay there as is. 4 to have a denominator of 3 at the moment has a denominator of 1. So it's now going to have a denominator of 12. Okay, how do I get the 12? I'm doing 3 times the 4 that was there. On the other side, so this fraction's okay, all on 3, it's all done. 2p minus 8, this all has a denominator of 1. So the 2p plus 8 all needs to be multiplied by 3. Okay, to get the common denominator. Okay, from here, I can multiply everything by 3 and get rid of all of these denominators of 3. So 3 times 4 is 12 minus, I'm subtracting p minus 6. I can't write this because this is only subtracting p. I want to subtract both of them. So I need to show that they're in brackets because I'm subtracting both of them. That was the common error in this question. Okay, from here I can do my expanding. Minus p plus 6. And expand on the other side as well. 6p minus 24. Okay, now I can collect like terms, so simplify this. 12 plus 6 is 18. Okay, and 6p minus 24. So I'm going to bring all the p's. So this minus p will come to this side, and this minus 24 will come to the other side. I'll be left with 18 plus 24 equals 6p plus p. Okay, so we get 42 equals 7p. Never leave myself enough room. 42 on 7 equals p. Okay, a lot of people seem to be like switching the equation around all the time, so we always get p equals, but that's not necessary. It's fine as is. All right, rearranging of formula. There's 2 questions. Yep, 2 questions. Okay, so I'm basically trying to solve for f and just treating this c as though it's a constant. Okay, trying to get f by itself. My goal is down here to have f equals just something here. All right, so I have a look at what happened to f. Okay, it's got 32 subtracted from it, and then it's multiplied by 5, and also divided by 9. Okay, these last two steps I could have written the other way around. Okay, because their multiplication and division are on the same level. We can change the order if we want. Okay, but we'll just leave it as is. So I want to get rid of these 3 layers so I can find f. Okay, like my pass the parcel. So I'm going to start by multiplying everything by 9. I'll have 9c on this side, and that'll remove that 9 on the bottom. Okay, I only need to multiply by 9 there. I'm not going to try and multiply inside as well. Okay, so I'll just be left with 5f minus 32. Okay, from here I can divide by 5. So 9c divided by 5 will be f minus 32. And I can add 32 to get f completely by itself. Okay, I have now rearranged that equation to get f by itself. Okay, this one's pretty challenging. Okay, but again, the idea is just to get R1 by itself. Okay, with something here that doesn't contain R1. Okay, I can't have R1 on the other side, because what I'm going to do is I could potentially be given values of R and R2, and I want to be able to sub these in here and get a value for R1. So if I've got R1 in here as well, rearranging having R1 on both sides won't help me out at all. Okay, so these ones take a little bit of creativity. There's a fraction here. I don't really like fractions, so I'm going to multiply both sides by R1 plus R2. So I'll have R1 plus R2, and it'll cancel out on this side. Okay, you can think that we'll just move this up to the other side, multiplying. Okay, from here I'm going to do an expansion. Okay, R1 plus R2 equals R1, R2. If we see here, I've got 2 terms that have R1s in them. So I'm going to get both of those terms to the same side. So I'm going to subtract R1 from both sides. So R2 will stay on this side. R1, R2 is still there, but I'm going to subtract R1. I'm still trying to get R1 just all by itself. The left hand side will stay the same. On the right hand side, I'm going to factorize. Okay, I've got a common factor here of R1. And what's left over is R2 minus R. And now I can divide both sides by R2 minus R. Okay, and I've got R1 isolated, and on the left hand side I can't see R1 there at all, which is really good. Means I'm done. Okay, the final one for the first page is find the equation of the line that goes through these 2 points. So I've got my equation y equals mx plus c. I don't know m or c at the moment, so I need to find both of them. I'll start by finding m. Okay, I'm going to call these 2 points x1, y1 and x2, y2. Use my formula for the gradient. 11 minus 3 on 5 minus 2. I end up with 8 on 3 as my gradient. Okay, now I need to find c. I'm going to sub in m equals 8 on 3, and I'm going to just choose one of these points to sub in. I'll choose the smallest one so that my numbers are smaller. Okay, into my linear model, and hopefully I can find c. Okay, so this is x and y. Y is 3, m is 8 on 3, x is 2. Okay, so 3 is 16 on 3 plus c. I need to get the 16 on 3 to the other side. So this is really 9 on 3 minus 16 on 3. I'm going to end up with c equals minus 7 on 3. Okay, so now that I have these two pieces of information, the gradient and the y-axis intercept, I can now write my equation. Some people didn't finish this off and write the equation. So the equation of the line is therefore y equals 8 on 3x. Some people wrote plus minus 7 on 3. Yeah, we don't need this plus or minus. If we're adding a negative number, is just like a negative number. I actually forgot to just show on this question, some people tried to just times everything by 3. If you're going to do that, you need to times all of these 3 terms by 3. So you'd go 4 times 3 is 12. This next term times 3 would be, so minus 3 lots of p minus 6 on 3. Okay, get rid of that fraction on the bottom, and then 2p times 3, 6p, minus 8 times 3 is minus 24. Okay, so if you were choosing the multiply by a constant option, you'd have to do it this way, which gets you to this stage, and you can solve as per usual.